welcome to today's geography lesson. My name is Cynthia Zondi and my co-presenter is Rina van Dierbon. This lesson is brought to you by Gauteng Department of Education in collaboration with Gauteng Discovery Center. Okay, boys and girls, we are today going to look into our lesson 5 of 2024, and the topic that we will be focusing our lesson on is what you were taught in this week, which is the valley climate, urban climate, as well as a bit of network. Okay, so let's look into our lesson objective, which is on the first topic that I have indicated to you, which is valley climate. So the subtopics that we will be handling or will be dealing with in this topic, we're going to look at slope aspects, and for this we need to know the definition of what is slope aspect. You also need to have an understanding of the effect on the distribution of temperature in the valley. We also are going to look at the definition and the development of both the anabatic as well as the katabatic winds. We are further going to look into the development of the inversions, the thermal belt, frost pockets, and we also are going to look at the development of the radiation fog. We also are going to look at how then these influence or impact on human activities, be it on economic, social, or environmental factors. And we also are going to look at how then this impact on the settlement as well as farming activities. All right. We are going to also further look into the urban climates, as I have indicated. And with the urban climates, we're going to look at the reasons for differences between rural and urban climates. We're also going to look at the development of an urban heat island. You have to have an understanding of the definition of what a urban heat island is. We also are going to be looking at the causes of urban heat islands, factors contributing to higher city temperatures. Then our lesson will progress where now we're going to look at the effects of urban heat islands, be it economic, social, and environmental. So we need to have a way in which we're going to deal with the problem that would be envisaged when we're talking about urban islands. Then we're also going to look at the strategies on how to reduce the urban heat island. Furthermore, we're going to look at the pollution zone. What is the definition of the pollution zone? What are the causes of pollution zones? We also are going to look at the effects of pollution zones, economic, social, and environmental effects. Strategies to reduce the pollution zone effect. And then I have indicated that our lesson has a bit of network which you were supposed to be, which I suppose that you were taught this week as the ATP. And for this week, we're going to look at the calculation and interpretation of the average radius. So let's look into the valley climate as I have indicated. So with the section of work that you are now busy with, you have to take note that we are now looking at microclimates, which we also refer to as local climate. So the word micro, we are looking at climate on a smaller scale, which then makes it a local climate. So the climate of a small area that is different to the climate of its surroundings. So we will be looking or focusing on that specific small area, which would be a valley in this instance. So when we look at the different climates that would exist in the valley, it would mean that their surroundings would have a different climate to it. So hence we refer to it as microclimate. Then one of the concepts that you were dealing with in your lesson is the concept of slope aspect. So this is the concept. And then what does slope aspect mean? It refers to the direction to which the slope faces. So you can have it maybe given to you differently, but the key thing here, we are looking at the direction to which a slope faces. So what is it that we are also emphasizing when we look at this concept? The impact that we envisage on the slopes, it changes during winter and summer. So the climate over the slopes would be different between these two seasons, during winter and during summer, because of the migration of the pressure systems. In our previous lesson, we were talking about the movement or the shifting of the ITCZ, which then impact on our pressure systems. And the three pressure systems that we discussed are the ones that are responsible for our winter as well as our summer. So the effect of your Kalahari high pressure in the interior, the South Atlantic high pressure cell over the west coast, and the South Indian high pressure cell over the east coast. So the movement of the ITCZ has now an impact onto our climate because of the migration of these high pressures. Okay, and then we also look into the position or the angle of the incoming sun's rays. As the ITCZ shifts between winter and summer, that would then impact on the angle of the incoming sun's radiation. Okay, so here you've got a diagram that is showing you a particular valley, which is where now we are illustrating the direction in which the sun's rays would hit these slopes differently. So you can observe there's this slope that has got an intense sun's rays, and we've got this particular slope that would have limited sun's rays. All right. So area A, which is this area that I am referring to, receives more heat from the sun. So which area is that? Area A. So when you look at the intensity of the sun's rays that is striking onto area A, it is more. The red arrows that you see here, these red arrows, they are the ones that are illustrating this point that I am referring to. So the sun's rays strike this area at a 90 degrees. So as you can see, there's an angle that has been drawn here to show that the sun's rays here are striking at a 90 degrees. So there is a 90 degree angle in which area KA receives the sun's rays, which therefore explains that it means area A would have more heat compared to the other slope that is facing away. And then also what you need to take note here is that this particular slope that we are talking about here, it is facing the north. So we are talking about a slope that is facing which direction? It is facing the north. All right. Then let's look at the effect of the sun's rays onto a slope that is facing the south. Now, area C, we are looking at area C here, which receives less heat from the sun. So the angle in which the sun's rays hit this is limited. And then the measurement of the angle in which area C receives the sun's rays, it is estimated at 45 degree angle. So there is limited amount of sun's rays compared to the large amount that we can see here at A. So there's smaller surface area in which the sun's rays are hitting onto area C. And then therefore the opposite is the opposite of what is happening on the slope that is facing the north. So this slope is facing the north, whereas this particular slope or area, it is facing the south. So take note of the difference of the angle in which the sun's rays have an impact on areas that are facing the north and areas that are facing the south. And specifically, we are referring to the slopes in South Africa. So, right. So there is more direct sun's rays onto the north-facing slopes. So which therefore says the north-facing slopes are more warmer than the south-facing slope. So this area A, it is more warmer than area C, which is facing south. So that is the explanation of aspect in the southern hemisphere. I've got more of the illustration of this point, where now we're looking at the valley climate in the southern hemisphere. Okay, so what you can observe here, this is the south, the direction in which the slopes are facing here. It is facing the south here, and then this we would have the north. So meaning that the direction in which both these slopes are facing, this particular slope and this particular slope, would have different aspects. So the north-facing slopes, as you can see, the sun's rays here are directly perpendicular to this particular slope, and therefore this slope tends to be more warmer. And then when you look at the slope that is now facing the south, the sun's rays, it's limited. So it only hits, can you see, even there's a shadow, there's a little shadow that shows that this particular area here is in a shadow, as well as this large portion of the slope is in a shadow. So there is limited sun's rays which would hit this particular area here. So then this makes the south-facing slopes to be in a shadow zone, and then the north-facing slopes are facing the sun. I mean, there's more direct sun's rays onto it, and therefore they are more warmer. So aspect in the southern hemisphere, we conclude that the north-facing slopes are warmer than the south-facing slopes, and then the south-facing slopes are predominantly dominated by the shadow zone. And then this would also impact on the winter weather, where now mostly areas that are in the shadow zone would be covered by large amount of snow in the areas that are snowing, like your Drakensberg areas within the Lesotho region and parts of the Free State. So those slopes that are south-facing are the ones that you would find more of the snow covering those areas. Whereas the part of the Drakensberg mountain, which is facing the north, we wouldn't find much of the snow. If there is an incident of the snow, we wouldn't find much of the snow covering those areas, because they are more into the direct sun rays and they are warmer. So this would just explain what you see in the diagram. So let's look at the points that I have been mentioning here, which are mentioned here. So we're looking at the north-facing slope. as well as the south-facing slopes. So the north-facing slopes are hot, sunny, and they are dry. And then they also have more direct sun's rays. Then the intensity of the sun, it hits a smaller surface area, which makes more concentration of heat over those areas. And then the type of soil that we find there, it would be warmer. The soil would be warmer because of the intensity of the sun's rays there, meaning the surfaces above the soil there would be warmer. And then farmers select slopes best suited for certain crops. So even when you are the farmer and you are settled around the areas that are within the valleys, it means you have to choose carefully where you do your farming activity. So, and you also look into the type of crop that you can grow in those specific slopes of the valley. So the type of a crop would be determined by the characteristic over which the aspect has an influence on. Then farmers have to know the type of crop that they would need to grow in the warmer slopes and the type of a crop that can survive the cold within the south-facing slopes. Warmer part of the valley is called the thermal belt. Remember, when during the night, when the valley of the slopes of the valley gets lose the heat through radiation, then the warm air would then be forced to rise, which then makes part of the valley to be warmer because of the warm air that escapes from the valley floor during the night because of the terrestrial radiation. And then the effect of aspect is greater in winter. So this is the time where we can emphasize the difference in aspect over the north-facing slope as well as the south-facing slope. So the perfect time to really feel the difference of climate within these different slopes would be in winter, and also in places that are further away from the equator, which we can all relate to the temperatures that we experience in the further south of South Africa and in certain parts that are north of the country. So that would be with the effect of places that are further away from the equator. Right, let's look at the south-facing slopes. What are the factors to note in terms of the slope aspect? Slopes, they are cool. So the south-facing slopes are cool, and they are also shady, and then they retain moisture because there is limited amount of evaporation taking place there. So these slopes, which I can relate to now here, is that they are cooler, they are shady, and those slopes can keep more moisture because of less evaporation taking place. And these slopes have got less direct sun's rays, so there is less direct sun's rays, and the surface area over which the aspect has influence, it would be over a larger surface. Okay, and then soils here are cooler, so the less intensity of the sun's rays would then make the soil to be cooler, as they are mostly covered or within a shadow zone. Also here, the farmers need to be considerate of the type of crop that they can grow in this particular slope, because they have to take into account which crops can survive the cooler temperatures, and they can also, which crops can survive the moisture that would be retained in those particular slopes. And then the area in the shadow zone is heated only by reflection. So the heat that would be striking on certain parts here would then be reflected back onto the slopes, especially that are mostly in the shadow zone. So shadow zone is only heated by reflection. As you can see, this part of the diagram here, it's darker here where there's a shadow. So the part that is lighter would be this part that you can identify here. So the reflection of heat from this surface to that area is the one that will make the shadow zone to be a little bit warmer, but not to a great extent. But heat would only be transferred to the shadow zone via the processes of reflection. The effect of aspect is greater in winter. The same way with the north-facing slope, the effect of the aspect is greater in winter. That's where in winter we can identify the areas that would be covered with snow because of the extreme temperatures that are low in the season of winter. Right, how do then the slope aspect have an influence on human settlement? So in mountainous areas where there are valleys with a steep slope, people tend to build their houses on the north facing. So people choose to settle where they choose to build their houses on the north facing slope, which then says they are considering the characteristic of aspect over the southern hemisphere, where we say the north-facing slopes are warmer. Then settlements are located in the south-facing slope, where in the northern hemisphere. So this would be the choice of settlement for humans where in the southern hemisphere. And then for humans that are within the valleys, when they choose to settle in the northern hemisphere, their settlements would be in the south-facing slopes, which means those are the slopes that would be warmer according to aspect. So we've got a diagram here that is showing us what I have just been referring to in terms of the settlement of humans there. So when we look into the southern hemisphere here, this is the south and this would be the north. So when you look at the position in which the houses are built facing towards the north, because this is where now we have that direct sun's rays that they would be experiencing. So this would be an effect within the south-facing slope. So this would be typical of areas around Lesotho. Okay. Then we've got this other diagram that is showing you the position. So you can see the position now in terms of the houses. Houses are facing towards the northern hemisphere. The choice of settlement here is within the north-facing slope. Then with areas that are in the northern hemisphere, within these mountain ranges that you can identify here, the people have chosen to settle where? In the direction that is now facing the south. So the houses that you can identify here are facing that direction. So meaning that people choose to settle in the south-facing direction. So their houses are on the north facing the south. Here, the houses would be in the south facing the north. So the area of the choice of settlement there would be mostly houses would be concentrated in those slopes that are facing the north in the southern hemisphere. And then the concentration of settlements here in the northern hemisphere, it is on the side, on the slope of the valley that is facing which direction? That is facing the southern direction there. Right, I've got a worksheet that would further emphasize or bring some clarity on what I've just been explaining. Figure 2.1 shows the influence of aspects on different value slopes located at 24 degrees 16 minutes south. Take note of the use of the coordinates there. That is a hint that I can give you in terms of understanding this question. And then there's the diagram that you have to refer to answer the question. When you look into the diagram, you must be able to determine which side of the slope is facing the north, which side of the slope is facing away from the north, which is the south facing. Okay, so before we get to the question, these are the things that I want to bring to your attention: the position of the valley, which we have here, the valley that you can clearly see here, and you need to take note of. Right. Then what are the questions that you need to look into? Okay, before I go to the question, I will go back to the diagram. I want you to take a look into the picture, and then if you can, just do some screenshots of what you are looking at there, so that you can be able to respond to the questions that I will then put up there. Okay, you must have taken the picture. Then here are the questions. Is the influence of aspect on the valley slope more evident in summer or in winter? That's your first question. Will slope X or Y receive direct rays of the sun? And then which slope, X or Y, will have the highest groundwater content? And then will slope X or Y be more suitable for crop farming? And then which slope, X or Y, is called a shadow zone? And then are settlements more likely to be located at A or B? And then would valley slopes closer to the equator be more or less influenced by aspects? So these are the questions. And the last question is, are forests more likely to be found on slope X or Y? All right, you've got 2 minutes to work on these questions, and you can then take maybe a screenshot of these questions so that you can be able to refer back to the diagram, that you can be able to answer these questions. Okay, boys and girls, I hope you have managed to work out your answer. We have these questions. Let's just look at the answers that have been provided. Okay, for the first question, it's winter. The answer there is winter, as I have already explained to you that aspect has got more of the influence in the winter season there. And then the follow-up questions which you would refer to, the correct answers would be as I have indicated there. It's X and Y for number 3. For number 4, it's X. Number 5 is Y. And then the slopes, the question on slopes would be B, and less the last one would be Y. So when you go back to the diagram, that's the explanation that we have in terms of how you need to consider taking your answers. I wanted to bring this to your attention to say that take note of these coordinates, which are bringing your attention to the fact that this would be in the southern hemisphere. And then also what I wanted to also bring to your attention is the fact that which slope between this slope and this particular slope, which slope would be the north facing. So your north facing slope, that's where we see direct sun's rays, it would be on this particular slope, meaning that this one would be our shadow zone. So the influence in terms of the crops would be on the warmer slopes, and the influence on slopes that would have more moisture would be on the south facing slopes. And then also in terms of the settlement, people would choose to settle where? On the slopes that are warmer compared to where people can choose to settle on the slopes that are facing away. So the choice of answers is for you to understand the diagram itself, because that's one of the things that you need to be careful of. Whenever you come across a question like this, there are certain things that you need to take note of, which can be of assistance for you to be able to know that you are working on a diagram that is in the southern hemisphere. Okay, so and for any clarity that you might still need in relation to this question, you are welcome to consult, and more clarity will be given to that. Right, we are now going to look at the anabatic winds. So these winds, we refer to them as the upslope winds because they blow up the sides of the valley when during the day. So they are referred to as upslope winds that blow up the side of the valley during the day. And then also what you need to note is that this it is a local wind which blows up the length of the valley during the day because of the rising warm air. So because of warm air that we find on the surface, then there is more convection when during the day. So the winds that would blow up the slope of the valley during the day would then result in what you call the anabatic winds. So here it's just an illustration of how then the anabatic winds develop. First thing that you need to note, it is during the day. It may not be written out as it is here, but when you interact with the diagram, you have to take note of guidance such as this. Okay, so it's during the day, and then so during the day we have the sun that would hit the valley and the valley slopes. So when heat accumulates on the valley, then warm air would be forced to rise. So we've got warm air that would rise up the slope. And these winds that blow from the valley to the mountains, we refer to them as the anabatic winds. And mind you, This circulation, we say, is a closed circulation because the warm air that rises would then cool. It will cool, and then there would be upper air divergence. So as there is upper air divergence, some of the air would then return back into the valley to close down the circulation. So this then concludes the circulation, and we then explain how the anabatic winds are formed. All right. So the cold air will then sink back into the valley. And what happens when the cold air sinks back into the valley? It will gain the heat again. So there would be the adiabatic heating as it descends down, and also the temperature that still has an influence over the valley floor would then make this cold air to change its temperature, and then it will get warmer again. So the air that will now be moving back into the valley would be warmer. So that is the explanation of how anabatic winds are formed. Then we're looking at how the katabatic winds are formed. So these, we refer to them as the downslope winds rather. They blow down the side of the valley during the night. So these, they blow down the valley during the night. And then this is a local wind which flows down the slope of a valley during the night because of what? Of the cold subsiding air. So it means the slopes of the valley, they get cooler, and then now that the cold air is denser, it cannot go up, but it would subside. So the cold air would sink down the slopes of the valley, and we refer to that as the katabatic wind. So the illustration of what I've just mentioned is that during the night, and take note of the animation there of representing the night there. So this is now during the night. The slopes of the valley gets cold, and as it gets cold air sinks down the valley because it's denser. Then when it sinks down the valley, we've got the winds that we now have that are blowing down the valley from the mountain to the valley floor. Then we refer to them as the katabatic winds. So these winds that are now blowing down the valley, we refer to them as the katabatic winds, and they form during the night. So to explain what further happens is that this cold air that trickles down the valley, it gets warmer as it sinks. So adiabatic heating takes place, and then the warm air will then settle at the valley floor. So with the characteristic of warm air, we know that warm air will then be forced to rise. So we then have warm air that will then be forced to rise. And as it rises, cooling will take place. So it will cool again. So there will be cooling, further cooling. And upper air divergence will then conclude the circulation. So as you can see, the arrows that are pointing sideways like that, they are indicating to you the upper air divergence. So this process now becomes a closed circulation because the cold air that is sinking will then go down the valley again, and then it gets warmed up, and then it will be forced to rise again. So which then concludes this circulation of how the katabatic winds are formed. And then let's look at the impact of the anabatic as well as the katabatic wind. So the anabatic wind, which is the rising air, it removes any pollution in the valley to higher altitudes. So because we've got air that is rising from the valley, pollution would then be lifted up to the higher altitude. Okay, and then with the katabatic wind, we've got cold air that is descending. Then it will capture pollution on the valley floor, which can result in the development of smoke. So the form of precipitation that would form as a result of the cold air that is descending then gets mixed up into the pollution that we find in the valley floor, results in the development of smoke. So that is how then it has impact onto the humans. It affects humans in that particular fashion. Right, with the explanation of how katabatic winds and anabatic winds are formed, then you've got the second worksheet, which is based on these katabatic as well as the anabatic winds. The question says, refer to figure 2.1, which shows air movement in the valley. So remember, our focus areas is in the valley. Choose the correct word or words from those that are given in brackets, and then you write only the correct word next to the question number. Okay, so then let's look into the diagram. What I can just indicate to you, the emphasis should be any illustration that you see on the diagram. And then also, again, I want you to take note of the information that I said you must take note whenever you are interacting with the question. And also, you should also take note of the direction and the direction of the arrows as indicated here. So you are going to also take the screenshot of this diagram, which will then, I will then have the questions that are linked to this particular diagram, which also are the low order type of questions that you can be able to answer as quickly as possible. Right. So I hope you have captured the diagram. Then here are the questions. Refer to figure 2.1, which shows air movement in a valley. Choose the correct word as I have indicated, and these are your questions. The valley wind A, is it a or an katabatic or anabatic wind? All right. And then this wind occurs during the night, during the day or night in valleys. Number 3, it is also referred to as a or an upslope or a downslope wind. Number 4, the zone labeled B is the thermal belt or the frost pocket. For number 5, the form of precipitation experienced at sea, is it frost or is it snow? And then, oh no, I need to go back to the questions before you can see the answers. Right, so these are your questions. And then you've got 2 minutes to work on it. And my co-presenter, Rina, will do the answers with you. And you have to have taken the screenshot that I indicated. But to some of the questions, you can be able to respond from your knowledge and understanding of the statement that is given. Right, your 2 minutes starts now.
Good day, grade 12 learners. Zondi gave you this worksheet 2 to complete, so let's go through the answers. The valley wind labeled A, is it an anabatic or a katabatic wind? Your answer must be katabatic. The wind occurs during the day and night in a valley. The word katabatic will give you the hint. It's a night blowing in the night. It is also referred to as an upslope or a downslope wind. Katabatic wind blowing in the night, so it's going downslope. The zone labeled B is the thermal belt. The form of precipitation experienced at sea will be frost. Very easy. I hope you have your 5 marks here for this question. Now we come to the inversion layer or the thermal belt in a valley. What is it? It's a layer of warm air above cold air in a valley during the night. A layer, like this, of warm air above the cold air. So I have cold air at the bottom, so then I eventually have this layer of warm air in a valley during the night. The layer of warm air above the cold frost pocket. It's that layer that is above the cold frost pocket. It is pushed up by the sinking cold air at night. Can you see that's the layer? The warm air. There I have cold air. Here also I have cold air. So this cold air is heavier than the warm air. Moves underneath and it start pushing this warm air higher up. So there's that layer. Here's the thermal belt on the slope, and that thermal belt is in the inversion layer. It occurs during calm, cold and clear winter's night. How? When the cold air drains down the valley, another word for drain is it flows down the valley slope and it collects at the bottom of the valley. There's my valley. So it flows or it drains down the valley slope. This air is going to be cold. The warm air is displaced upwards to form an inversion layer in the mid-valley. So this cold air is now going to force this move underneath this warm air, and it's going to force this warm air to move higher up. And I have an inversion layer in the mid-valley. Mid-valley is in the middle of the valley slope. It's a layer of warm air trapped between 2 layers of cold air, and that layer is called the thermal belt or the inversion layer. It can lead to the formation of acid rain, which can corrode buildings and it can damage crops. So it's day, sun is shining. So during the day the land is heated. Then at night the surface cools off. I have cold air and it forces the warm air to rise. So there's my cold air, and my cold air has forced this warm air to rise during the night. There's a very nice diagram to show you. This red line here, you can see the temperatures. It's cold here at the bottom, so it becomes warmer, so warm, and then higher up here it is cold again. So it's basically this part in the middle, mid-valley, where temperatures is warmer, as this cold air that sinks down has forced this warm air to rise, and it is there in that layer. Now this air is also cold. This is also, so it's a layer of warm air trapped between cold air from above and from the bottom. Now a frost pocket is a pool of cold air on the valley floor at night. which can reach dew point temperature below 0 degrees Celsius. And then if I have that, I have frost. Its low-lying area, for example, the valley bottom, where the frost occurs more frequently than in the surrounding area. It is normally after a dry, clear, cold night. No clouds. The cold air drains down the neighboring slopes, and if the dew point temperature is below freezing point, it condenses and it forms ice crystals. And those ice crystals is called frost. The forming frost pockets is where the cold air collects. So, there I have my frost pocket at the bottom. I have the cold air. Remember, it's night, the cold air sinks down. That air is cold. There's my warm inversion layer with my warm air. Now, when this cold air reaches dew point temperature below 0 degrees, we have frost. Radiation fog develops at night in a valley. When radiation occurs, when radiation causes the heat to be lost quickly and the air mass reach dew point temperature. On a cold, clear, cloudless night, that means it's cold, there's no clouds, there's no winds. When terrestrial radiation occurs rapidly, the ground becomes cool. The air above the ground is also cool, and when this air is below dew point temperature, it causes water vapor to condense around the dust and other particles in the atmosphere, and it's going to create radiation fog. It's like a low cloud. In the morning, the sun's rays hit the surface, the warm air rises and evaporates, and if I have a combination with pollution, it will form fog. A combination of this pollution and this fog, we call it smog. Okay, so here's an example of my fog that forms in the valley. At the bottom is that low cloud. The cold air drains down the valley. It reduces air at the bottom, and I have fog. In reality, here's how it looks. This white part close to the surface of the earth. What is the impact on the environment? It traps pollutants. This will differ depending on the activity in the area. For example, industries will result in more pollutants being trapped. We can have acid rain that can occur, and this acid rain can damage fauna and flora. It affects the farmers if the frost-resistant sensitive crops are grown on the valley floor. Farmers therefore must plant frost-resistant crop, a crop that can grow in this cold temperatures, that will not be damaged with frost. It damages the natural vegetation and the crops if they are there, so therefore we have to make sure that we can plant crop-resistant crops. How does it impact humans? A frost pocket can cause people to settle in the middle slopes in the thermal belt. The smog that I spoke about, the pollution in combination with the clouds, can cause poor visibility, and it's a health hazard. It can cause sinusitis. If you drive in a car, you can't see properly. It can cause traffic accidents due to poor visibility. It affects the people's health, for example, respiratory illnesses. And now, what is the influence of valley climates on human activity? Settlement. People will settle on the equator-facing slope. We call this the north-facing slope, as it is warmer in the day in cool areas, but it's warm areas when the cold air faces the pole, the south. People settle in the thermal belt above the frost pocket because it's warmer there at night. Farming. Stock pens are built above the frost pocket in the thermal belt to avoid stock losses. The lower parts of the valley is used for grazing. The frost-resistant crops are planted on the valley floor. Frost-sensitive plants are planted in the thermal belt. And then a crop that needs a well-drained soil, a crop that needs a soil where there's always water in, with a lot of sun, are planted on the slope that face the equator. Boys and girls, let's quickly look at a video that's covering this valley climate.
This that I'm going to show you now is the basis of inversion. It's actually the basis of valley climates, especially during the evening. Now, what we've got here is that we've got here katabatic winds and inversions. Now you remember this is happening during the night, right? Now, easy to remember katabatic during the night. Cats walk during the night. Okay, here we go. So what happens is that the air has cooled off. And what happens when air cools off? It sinks down the valley slope. And we've got that. Look at our arrows here. The cold air sinks down the valley slope. Very, very important that you see that. Now, as it sinks down the valley slope, this warm air is being displaced upwards. Now, what's happening now? This means that here was warm air and here was cold air. But the cold air forced the warm air out. Now the warm air is on top and the cold air is at the bottom. But you know, you say, hang on. Isn't it that the higher I go, the colder you get? You're right. But we are dealing here with inversions. That is why. What is an inversion? An inversion is when the temperature increases with altitude. Let's just put it to you bluntly. The higher you go, the warmer it will get. Okay, so this means that here I'm going to get warm air instead of cold air because the cold air forced the warm air out. Okay, this means because it's so cold there at the bottom, I'm going to get a frost pocket there. I'm going to get smog there. And we are going to have huge problems for farmers because you won't be able to plant all these crops here. You will have to plant frost-resistant crops here. And those who are sensitive to crops, to frost, you will have to plant there. Now, this is the basis of valley climates. Now, during the day, just the opposite happens. What happens? Your valley is being heated, right? And what happens today? It rises up the slope, and then you get your adiabatic effect. But these ones that we're talking about here, these ones are the ones that usually tested because of the big influence it has on humans and the settlements. Okay, let's have a look now. Now, you must remember that this air, as it moves down the slope, then it means there was a high pressure on the slope, and here in the valley was a low pressure because winds or air always moves from a high pressure towards a low pressure. Now, this forms the basis of this exam question. And this exam question is very, very important. Last year, here's the question. Study the diagram on valley climates, and I must answer the questions that follow. Let's have a look at this. Name the wind 1 in sketch A. Here's sketch A, the wind 1. Right. Now remember, it can only be one of two, the katabatic or the adiabatic one. So, that's it. So we've got the adiabatic one here in the day, and the katabatic one during the night that we've got there. Okay. Now, the second question, state one difference between the winds 1 and 2. See, there's winds blowing there, and these winds 2 blowing there. Right, what's the difference between them? Here we've got it. Firstly, the one occurs during the day, this one, am I right? And this one occurs during the night. First difference. Second difference, what we've got here is that this one is occurs because of heating. In other words, it's warm air that rises. This one has to do with cold air that sinks. Another difference between the two. Another difference between the two would be that this one wind blows from the valley upwards, and this one blows down the slope. Okay, so those are the differences between these winds that we've got. Now, here we've got, would wind 1 or 2 originate if a higher pressure occurred at the top of valley? Which one of these two would occur when the higher pressure is at the top of the valley? Remember what we have learned in grade 11. We have learned that winds always blow from a high pressure to a low pressure. Remember that. Okay, so the question says, Where would wind 1 or 2 originate if a higher pressure was at the top of the valley slope? Now, let's have a look. Top of the valley. So this means that's it. Winds always blow from a high pressure to a low pressure. Look at my arrows there. Okay? So it's very important. And the reason therefore is that the wind blows from the high pressure to the low pressure. Very important that you should know that. Okay. This one, actually the students didn't answer this one very well. Explain why visibility on the valley floor, this here at 3 at the bottom, is less on winter mornings. Draw a label diagram to support your answer. Remember what I said about diagrams? Very important. So, why is visibility less? Visibility is less because we've got a lot of smoke and pollutants here. What's happening? This is happening. The cold air rolls down the valley. Here we've got it. Alright? And the inversion traps the smoke here at the bottom. Alright? And the result is that you have poor visibility. Now, the matrix last year had to supply a diagram as well. Can you see where the diagrams come in? Why it's so important? They would have got 2 marks for the direction, and they would have got 2 marks if they indicated the correct place where smoke has been formed. Matrix, do you see why I'm saying your diagrams are so very, very important? Okay? So please practice your diagrams. These are easy marks, people. Okay? And see that you really can gain the maximum marks when you write your exams or tests.
Thank you. I also want to elaborate on what Mr. Glenn Kamai said. It is very important to study and to be able to also draw a diagram on each of these dots. Boys and girls, we go over to urban climate. Urban heat island, it is when the city has warmer temperatures than the surrounding rural area. So this is my rural areas. It means my temperature over the city with all the buildings is much higher than the area in the surrounding rural area. This is a concept and we want you to study those concepts. Next. The reason for the urban areas to be warmer are things like buildings, concrete, your pavement areas are concrete, and we have lots of motor vehicles in the urban areas that creates pollution. And then also in the urban areas we have industries together with the vehicles that is causing air pollution. Some buildings are made up of glass. Glass reflects heat back, and that reflection is heating up the temperature. Now if you look at this diagram, you will see the natural areas, the rural areas has got natural surfaces. It's either grass or it is gravel. In my rural areas we have less pollution with few or sometimes no industry. They also have small heat absorbing surfaces. There's very less tarred roads or concrete that absorbs the heat. And in the rural areas have much less people staying there that can create pollution. There's also fewer cars. Where the urban area, we have lots of artificial surfaces. Artificial surfaces mean surfaces where we cover the natural areas with tar or cement or with concrete, pavement. We have lots of high-rise buildings. There's my high-rise buildings in the urban areas. Those high-rise buildings have air conditioners. So I want to invite you to go to any building where there's an air conditioner. Inside it's cold, but the air that goes out at the back of the air conditioner that goes into the air is hot. We have industries that produces pollution, many cars, large dark surfaces like tar roads. We have lots of people that move to areas. We have lots of pollution. There's a lack of vegetation. We don't have that much trees or grass surfaces in urban areas. So what are the causes of a rural climate? Pollution from the industries, domestic fires, car exhaust fumes, burning of fossil fuels, inversions that trap the pollution. Urban climate, Building material, as we said, concrete, tar, brick, and all those things that can absorb heat. We have buildings, tall buildings that trap the heat. We have air pollution that helps us to trap these heat. The people are burning fossil fuels, transport, many cars, trucks, lorries, buses, industries that release heat. Some shops have central heating, and then we have a large concentration of people. Now the question is, what is the effect of the urban heat island? It causes human discomfort. You are tired. It's very, very like I'm sweating in this warm area. It's very discomfortable. People can get heat stress, and some people can even die if it's too hot. Then we have the release of greenhouse gases like carbon dioxide. We have smog concentration, which will cause reduced visibility. In the mornings, they can tell you if they give you the traffic update, they can tell you there's lots of smog in the area, be careful. The increased use of energy in summer, pollution levels can increase. Now the question is, how can we help, or with which strategies can we come up so that we can reduce this heat island effect? We can start by making surfaces lighter colors to be more reflective and less absorbent. It must not absorb the heat, it must reflect it back. We can have greening by cities by planting trees in gardens, onto pavements, in parks, reduce our paved areas and bring in more grass or trees or shrubs. Trees can increase transpiration, which will decrease and release oxygen. Trees can reduce the energy cost as it has a very natural cooling effect. You can also have nice fountains in there. Plant roof gardens on top of your tall buildings. Have roof gardens which can absorb the heat and the pollution. Invest in energy saving strategies like solar panels, grass roofs. Develop sustainable public transport. Implement building restrictions on height and materials used in these projects, and do not use glass or any reflective substance as a building material. Also control the amount of pollution from factories. You can even find them. We now come to the term a pollution dome. It's a trapped mass of polluted air over the city. And here you can see it is like a dome. Warm air is trapped in the city. You can see the air circulation here. It doesn't get out. It is when dust, soot and chemical emissions are trapped in the warm air of a heat island, the dome becomes a pollution dome. The pollutants are hygroscopic nuclei and attract water vapor to them, and fog develops. Because of all the pollutions forms hygroscopic nuclei, and we get water vapor that forms around these hygroscopic nuclei, and it will form fog. Smog is a mixture of smoke and fog. There you can see our pollution dome. I want you to check now. There's a difference in shape of a pollution dome during the day and during the night. During the day, I have convection of air that's moving around in the center of the city, which causes low pressure. You can see this is my low pressure, my air rises. Lots of activity. The warm air rises vertically, cools down, and it diverts, there you can see diverts, into the upper air to spread outwards to the rural area. The air circulation in the dome spread the pollution vertically, and it's more dispersed. The pollution now is carried away by the upper air divergence. You can see there how it's moving it away, although I have my sinking air there. So during the day, all these activities makes this pollution dome less evident. The cooler air flows into the low pressure cell, from the surrounding rural air. Look at the situation at night. The cooler air at night results in a pollution dome which develops close to the surface. Therefore, pollution is very dense and it cannot go out. It cannot escape. It forms that there it is stuck. It can't go out, so it forms a dome. It's more concentrated because of the inversion layer closer to the earth, and the pollution cannot escape. So you can remember, cold air sinks. Causes of the pollution dome, again, vehicle exhaust, carbon monoxide, burning of fossil fuels, the pattern of circulation and high levels of air pollution in the city. And then what is the effect of the pollution dome? It's blocked during the day. Precipitation increases as the pollution is condensation nuclei. It can trigger allergic reaction. People can have breathing difficulties. It can cause asthma attacks. It can lead to poisoning from petrol. Smog can reduce visibility. We have a global climate change that can occur. How can we reduce the pollution dome effect? We can again make the surface lighter colors, green areas, trees in gardens, parks, the trees increase transpiration, building restrictions on height and materials used in projects, energy saving strategies, sustainable public transport, and to reduce energy. The trees can reduce energy costs and to control the amount of pollution by the factories. The map work for the week, boys and girls, was gradient. The calculation of gradient. What is the formula? It's vertical interval divide by horizontal equivalent. How to calculate gradient? The vertical interval is where you measure the difference in height between the 2 points. You have point A and B. So what is difference in mathematics? It means I must subtract. So I have point A, I have point B, A I have height, B I have height. So I basically have to subtract the height. The horizontal equivalent is the actual distance between these 2 points. Remember this when we calculate horizontal equivalent. You actually measure the distance between A and B with a ruler and a pencil. You multiply it by 500 if you calculate from a topographical map, or you multiply it by 100 if you work orthophoto map. So I say there I have my two areas. There's my spot height 2263. Spot height 1797. Step 1, I must determine the vertical interval. I'm going to subtract the two heights. Remember, height is meters. Horizontal equivalent, there you can see we have measured it for you. You might measure it yourself. So it's 3.8, it is centimeter. What must we do with it? We must make it meters. So I'm going to take that 3.8 times it by 500 to get 1,900, because I'm working with meters there, I must have meters here as well. It's a topographic map, I'm going to times by 500. So on the top there must be my meter, and at the bottom I have that one. So please make sure you do the correct substitution. Then I have to divide 466 by itself to get 1. Then if I take 1,900 divide by 466, I will get 4.07. Sorry, 4.07. 1 over 4.07 is exactly the same than 12407. Your answer must always be 12407. For every, what does it mean? For every 1 meter that you move horizontally, the elevation is 4.07 meters. Every 1 meter that I walk, my slope will increase with 4.7 meters. The question now, is it steep or gentle? It is steep. Okay, worksheet 3, boys and girls, there's an orthophoto map. I'm asking you to calculate the average gradient from 0.6 to 0.7 in block B4 on the orthophoto map. And then we want to know, is the average gradient steep or gentle? Okay, I'm going to go through this with you as time is not on our side. If we subtract, you'll see there it is 20. I read it off, there's 20. Here you can see I have 80, 75, 70. I follow the contour line. So I have 70 meters minus 20 meters give you 50 meters. You can see where you get your mark allocation for. Then if you measure from there to there, you will get 5.4 centimeters. Look there, you get a mark for that. Ne? I'm working on my orthophoto map, so I must times it by 100 meters. So if I do that, I will get 540 meters. Now I do the substitution like in the previous one, and there is your gradient. 1 to 10.8, and it's a very steep. From 1 to 12, it's normally a steep gradient. Boys and girls, thank you very much. Good luck for the next week's work, and make sure you study the work we did in the class this week. Thank you very much.